Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Knowledge Park 3, Greater Noida. The subject that I teach in this semester is digital communication. This particular subject is for electronics and communication engineering students, and the topic that I discuss today is delta modulation. Actually, delta modulation is a source coder, means it converts analog signal into 1-0 bits. So delta modulation is a source coder. The advantage of delta modulation is that one bit is transmitted per sample. If you compare this with pulse code modulation, where 3 bit is transmitted per sample, but here only 1 bit is transmitted per sample. That bit is a 1 if that bit is a 1 if the current sample is more positive than the previous sample, and a 0 if it is more negative. The meaning is that each sample is compared with previous sample in delta modulation, right? If the present sample is more as compared to previous sample, then 1 bit is transmitted. If the level of present sample is less than the previous one, then 0 is transmitted. This is the basic concept that involved in delta modulation. So with the comparison with the samples present and previous, delta modulator decide whether 1 is transmitted or 0 is transmitted. Right? So this is the two important points or concept of delta modulation. If you see these in this particular picture, we have two signals. One signal is analog signal. This is analog signal. And this analog signal is a information signal or a message signal. Empty. This is small empty, right? Second signal is a staircase signal, right? And this staircase signal follows analog signal, and the staircase signal is represented by MQT, right? And the step size of this staircase signal is del. Look at this del. And the time period of each stair is TS. Look at this TS. Right? So this staircase signal MQT follows MT. So MQT follows MT. Right? So when this analog signal, or you may say that if the slope of this analog signal is decreasing, then in this case, when you compare sample with present with previous one, then you will find that it is always less than with the previous one. Means present sample is always less than the previous one when the slope of analog signal is decreasing. And in this case, zero is transmitted, or zero will be transmitted, right? So if you see in this particular picture, in the initial stage, the slope of the analog signal is decreasing. So the staircase signal output is zero. Look at this zero. And the time when this analog signal increasing, the slope is increasing, or it move upward, then in that case, the sample of present sample with previous one is always high, is always more. Means present sample is more, or you must say present voltage sample is more as compared to previous sample voltage, and the staircase signal's output is 1. So one will be transmitted, then 0. Look at this sequence. Look at this binary sequence at the modulator output. So the modulator output is either 0 or 1, depending upon the slope of analog signal. So the output of the modulator is 1 when present sample voltage is more as compared to previous voltage level, and simultaneously the modulator output is 0 when the present sample voltage is less as compared to previous sample voltage. So 0 will be transmitted. So in that way, this delta modulator works, and this is the process in delta modulation, right? But one thing is very important. Every sample is converted into 1 bit instead of 3 bit that we take in the case of PCM system. In pulse code modulation system, the output of the PCM transmitter is 3 bit at every sample. But here, only we have 1 bit with every sample. So the same information is to be transmitted with lesser number of 0 and 1. That is why the requirement of bandwidth is less in delta modulation. Look at this picture of delta modulation. Here, figure A is delta modulator transmitter, and below is a picture of delta modulator receiver. So in delta modulator transmitter, look at this comparator. Comparator compare present with the previous bit. Look at this Mn. Mn represent present bit, MQN minus represent previous bit. Sorry, previous sample. So this Mn is present sample and MQN minus 1 is previous sample. Comparator compare this, and if the compare found which one is more, either Mn is more as compared to MQN minus or less, it gives its decision En, right? That En either a positive voltage when Mn is more as compared to Mqn is when it may be negative. So on the basis of this comparator output, encoder encode it either 0 or 1, right? And this EQN, which is the output of quantizer, become the previous bit for the next sample of Mn, isn't it? So the output of the DM wave is a string of 0 and 1. And this string is to be reached at the receiver. And at the receiver, decoder is very much important because decoder do a reverse operation as compared to encoder. Here, 0, 1 bits are converted into a real voltage labels. And these voltage labels is to be smoothened by this low pass filter. And output of the low pass filter is a massive signal, which is the input of this delta modulator, sampled massive signal. So in this way, the signal is reconstructed. So in this process of delta modulations, two noise come in the picture, or you may say two errors come in the picture. One is slope overload distortion. This is slope overload distortion, and this is granular noise. The two noise or two distortion come in the picture, or you may say two errors come in the picture. One is slope overload, second one is granular noise. Now, question is, when this slope overload distortion comes? The slope overload distortion come in the picture when the slope of this analog signal is very much high, so that your staircase signal is not follow this empty properly. So in this way, this empty is far away with MQT. So your staircase signal is not follow properly with empty because the gap between empty and MQT is more. And this is the case when the slope of the analog signal or the mass signal is more. So whatever the 0 and 1 converted, it is error. The error come in the picture because ideally your staircase signal should follow the analog signal. But in this case, because the slope of the massive signal empty is more as compared to staircase signal, because the step size of the staircase is fixed. When your step size is fixed, then there is no variation in staircase signal. And because of that, this staircase signal is not exactly follow this empty. And error come in the picture, and that condition is slope overload distortion condition. Second one is that sometimes what's happened when slope is very much less, or you may say when your analog signal is uniform with respect to time, is level, then again there is a condition. In that case, the slope of the staircase signal is more as compared to analog signal. And again, there is a difference between staircase and analog or your massive signal, and that creates a noise, and that is granular noise. So it is clear that when slope of analog signal is higher than the staircase signal, then slope overload distortion comes, and when slope of staircase signal is higher as compared to massive signal, then granular noise comes. So in this way, and this is very much important as far as examination is concerned, because out of 10, 6 times this particular question is asked in the examination, main examination. Slope overload distortion and granular noise distortion as far as delta modulation is concerned. Then merit and demerit of delta modulation. 1 bit code words for output means on each sample convert only 1 bit, 0 or 1. Low signaling rate means less number of bits is transmitted as compared to PCM. So the requirement of bandwidth is also low. So low channel bandwidth. And no analog to digital converter is required, which is the case of PCM system. So here no A to DC converter is required. So that's why this DM is less complex as compared to PCM, right? But demerits that we already discussed in the previous slides is slope overload present and granular noise present. So there will be the possibility of these two types of noise or distortion: slope overload distortion or noise and granular noise distortion. These are the demerits and the merits. But if you compare with merit demerits, merits are more as compared to demerits. Thank you very much.